afternoon to all of you. So, before starting my talk, let me ask, how many of you are on social networks? How many of you use Gmail? Fine. So, nowadays, most of us are on social networks, right? Most of us are making use of a Gmail, correct? So, have you ever thought of that how to persist this particular data? The data that is existing on a social network, that is existing on a Facebook, Twitter, how to particularly persist this kind of a data? Have you ever thought of from a database perspective? And the tremendous amount of data that is being generated nowadays. So, my topic will be dealing with this particular talk, starting with how to persist the data and what are the particular research challenges faced during persisting the different kinds of data. Right, so I'll be simply giving you an introduction of a big data, different types of data, a database perspective to it, what are the how to deal with different types of data, then what are the current trends among the data, what are the research domains, and finally the references to it. So this is while I'm talking about a big data, correct? So it means that in each and every sphere of the life that are existing nowadays, there is big data. Now what is this big data? Is this that, okay, this many terabytes or this many exabytes of data leads to a big data? Is this the definition of the big data? How many of you agree to this one? Is this the big data? Just dealing with the corresponding, okay, this much, hexabytes, exabytes, petabytes, terabytes, is this the big data? Is this only the complete definition of the big data? No. When we are dealing with the volume, the velocity and the veracity of the data, then it means that I'm dealing with the big data. But how this data is being generated is nowadays each and every sphere of the life is generating a big data. So you can see that, okay, this is some particular thing being taken up. Okay, 24 million transactions processed by Walmart, 100 terabytes of data uploaded to the Facebook, 175 million tweets on the Twitter. Now the question is this one, how to store, how to query, and how to process this particular data efficiently. So currently we are just working at the front end of it, and we are just doing something called as a chat on a Facebook. We are just dealing with the data, and irrespective of how at the back end the data is being persisted, the data is being stored, how we are getting our query results, we are least bothered about that. Many of us are on Amazon also, right? And Amazon usually had at a lower end, okay, these are the recommendations for you, right? Have you ever thought of how these recommendations are coming to us? How come? Based on our history, somebody is analyzing our data, somebody is doing a big data analytics on our data, correct? And based upon that, is giving a result to it. But who is doing that? The database domain people, the database researchers are the ones who are working on that particular part. So Amazon has a DB researcher team at the back end who is particularly working on this particular data and giving the results for the customers to work on. So here lies the research. So if you are being deployed to a company like an Infosys or a TCS and working on the front end as a software engineer, your package may be up to a 10 lakh. But if you are really working on a database side, your package may be just double of that. And if you are working with a Gmail, your package may be just thrice of that. Because the way they store the data, the way they query the data, and the way they process the data in an efficient manner is an area of research. Right? So this was the traditional way how we were storing the data, how we were dealing with the volume. We just have the gigabytes. Now, big data is constantly being updated, as for example, the Facebook, the Twitter, and the others, generated per hour, day, and it's more rapid. The structure was simply a structured one. What do I mean by a structured one? It means that if I'm storing the student information, I'm very good at storing, okay, this is the defined schema of the student information. He has a name, he has an enrollment number, he has a particular grade, he has the subjects. That's it. So it's quite structured. Right, but now if I'm chatting to you on a Facebook, what happens? I'm doing something as an unstructured thing. If I'm putting a Twitter tweet over there, right, so it's like an unstructured kind of a thing. And if you just have a glance at the, if you just see a web page and just right click it, Okay, right click it, view source. What is there? There's some particular tags over there with /XML and /XML and something written in between. So that is referred to as a semi-structured data. Means some kind of a data is there, but it has some structure related to it. So it means that we have to deal with the structured data, we have to deal with a semi-structured data, and finally we have to deal with an unstructured data. Correct? So the data source earlier was, if I am dealing with an Oracle, it says okay, we have a centralized kind of a system, but nowadays we are dealing with what? Distributed databases. Distributed databases means our data is across different sites and we are connected through the network. So we are into a distributed system. So while we deal with the cloud computing, we are dealing with a distributed. So X is interactive, then batch or real time. Data stored earlier, when I was dealing with a structured kind of a data, I was persisting the data into a database management system called as a relational database management system. But what will happen if I store your chat into an RDBMS and I make a column into that, okay, chat. So the chat between you and me may be so long. So is it possible to persist the data and then to waste the rest of the space into an RDBMS? Because I have to allocate a space, I have to allocate a column for that, I have to fill in every tuple. So it means that storing that kind of a data may not be possible through an RDBMS. I have to compromise for a storage space. So now there are particularly databases that can deal with it. So with the emerging market, there is a NoSQL, there is a HDFS that is being persisting into the market to deal with other kinds of a data, which I refer to as semi-structured data and unstructured data. So this is what I dealt with, the structured, the semi-structured and the unstructured data. So now what basically a database is and how is it different from a database management system? I think that some of you might be aware of a DBMS. Some of you might be aware. Okay. For others, I'll just give a brief introduction what a database is. So first we have a data, that is something raw. We convert it into an information with some meaning. Then we extract the knowledge out of it, and finally we have a wisdom. So this is just an example of it. 160 by 110 doesn't make any sense until and unless I add a degree, append a unit to it, 160 by 110 mm per Hg. Then patient X is a high blood pressure, right? So this is the knowledge I extracted because the normal range is 80 by 120. So this is the particular knowledge I extracted for it. Then how come it converted into a wisdom is patient X needs to be investigated for the cause of hypertension. So what a database is, I have the data, I converted it into an information, I extracted the knowledge from it, and finally I can provide a wisdom to it. So doctors can simply do this kind of a system. So despite of manually going to a doctor, we can have a decision support system which can do this particular thing for us. So now, why do we need a databases? Right now, Flipkart, Amazon, Gmail, every particular thing that is being existing into the market mostly are making use of a database to store their particular data, to persist their particular data, right? So this is, this basically is a DBMS. So how database and database management system are particularly different is, a database management system is a set of a software that are used to define, store, manipulate and control the data in the database. So if I just take an example of a student management system, and all of you might have a corresponding online portal for registering, so your teachers might be having a different access to it. Correct, and you might be having a different access. You can just see your grades, whereas your students are, whereas your teachers are able to modify your grades. Correct. So that lies the control. It means the database administrator can define the control. Okay, this is the student category and this is the teacher category. Right. And your teachers can manipulate your grades, but you cannot manipulate your grades. Correct. Manipulate means update your grades. If in case there is a false information or some totally mistake is there, your teacher can manipulate that. Then store the data, your teacher can store the data, you can just have it in a read-only mode. Define the data types, okay, your name is to be varchar or your name is to be numeric. So that particular data type is being defined. So DBMS is a set of a software. So this is how. So this is the stored database. This is the stored database definition, means the data about the data, metadata is being stored over here. Then you correspondingly connect it, you have a software to access this particular stored data, you have a software to process the queries program, and finally here is the application users. So currently if you are not being aware of a DBMS, and all of us, and even a layman, the one who is using a WhatsApp, the one who is using a Facebook is at the application end of it. So I'll call it as a front end user, correct? And irrespective of what is happening at the back end, so we are just dealing with the front end. And we want everything to be into a fraction of seconds, irrespective of how the queries are being handled and how it is being able to retrieve the results for you. So we are just concerned with within a fraction of seconds I should be able to retrieve the data item. So this is the work of, so this is just a history of the database management system. We started with the file system, moved on to the hierarchical and the network, then we moved on to the relational databases which are still prevalent into the market. So the question is when to go for a relational database and when to move on to an object oriented to that, when to move on to an XML, and finally when to move on to a NoSQL. And then the question arises, if I am persisting one kind of a data into a relational database management system, then some other kind of a data semi-structured into an XML database, and finally an unstructured kind of a data into the emerging that is called as a not only SQL, how a single front end will deal with all of this. Any answers to this one? I am storing some part of your information. Let me take an example of a Facebook. Facebook, you have a username and a password, correct? So your username and password is something which requires a high level of security, correct? So it means that I may be aware, okay, this is something very fixed, every user has it, a username and a password. So I chose a relational database management system to persist it because its schema is well defined. So, and because of strong security mechanism, I usually use a relational. I'm just giving an example. I'm not quoting what in actually Facebook is doing it. But this is just my perception, okay, to give you from a point of view, okay, how the data is being persistent and which particular kind of a database is being used. Then correspondingly object-oriented, because the emergence of the object-oriented programming languages came into existence, that is Java, C++, we need to have a particular database for that, so that is why this came into the market. Now, since we moved on to the web, right, so we thought of, okay, since we are into the internet age and let us persist the data the same way as it is existing onto the internet. So that is why we choose an XML database. And finally, we moved on to deal with the big data and the distributed database systems concept, we chose a NoSQL database. So this is the evolution of the database technologies. We started with this place and this is how we move on to this one. So this is where the NoSQL is. This is where some of the examples of the MongoDB, the Cassandra into the market, and recently I'll have a brief intro about a new SQL too. So now, while I'm talking about, I categorize them as a schema-based and a schema-less. Right. So schema-based means my schema is quite defined for a student, the name, enrollment number, the grade, and the subject. Right. And the schema-less means not having any particular schema and I can store it in the form of a key value. So I'll show you an example even for that one. So these are the advantages while I'm storing it in a schema-based database. It has a fixed schema, it has an advantage of structured data, and it provides strong transactional support. Right now we are doing our financial banking transactions, correct? So what it says is, if I'm doing a fund transfer kind of a thing, either it should happen at all or it should happen at none, correct? All of you agree to that? So it means that the fund transfer is a kind of a transaction which needs to follow the property of the asset. A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. It means that transactional support is providing an asset to a financial banking transaction. कभी ऐसा होता है कि A के अकाउंट से डेबिट हो जाए और B के अकाउंट में क्रेडिट ना हो, आइदर तो A के अकाउंट में पैसे वापस आ जाएंगे या फिर फंड ट्रांसफर के केस में A से B से ट्रांसफर विल बी कंप्लीट. So that is a full transactional support. So that is why till date we are relying on a schema-based database, that is an RDBMS. So if we consider an HDFC or an ICICI, all of them rely, okay, this provides a good transactional support, so let us store this kind of a data into an RDBMS. Then what about a schema-less database? It says, okay, I'm very much flexible. I don't need to have a defined schema. I can store the data at any particular, in any particular way. Right. For example, if I give you an example of, okay, healthcare domain, and if I consider a new disease emerged into the market, right. So now, do I go and change the complete schema, add a particular column to it, and then add the name of the that particular disease? A 4D ultrasound is being introduced. For example, till now 3D was there. A 4D came into existence. This means, do I need to change the schema? So despite of that, what it says is, no, let me save it in a flexible kind of a thing. So let me deal with an evolution of the data, right? So my data is constantly evolving and I need not have to change my schema, correct? And I can deal with a flexible kind of a schema. So let me save this kind of a data into this one. Then it has a high scalability, it is partition tolerant. Then what are the particular disadvantages while I'm dealing with a schema-based databases? It has a limited scalability. I'll come to this one thing called as a scale up and there's one thing called as scale down. Okay, so limited scalability, limited modeling capacity. So the best example is Microsoft MySQL or Oracle MySQL, and here the example is a MongoDB. Correct? So this is what I told when I'm dealing with, so this is what it provides. These are the database languages. Okay, now the disadvantages of the schema-based. Schema-based says that while joining of two particular, there is one concept called as a relation or a table. Okay, so while I'm combining one table to another, what I have to do is I have to join the relations. And since I have to join the relations, that is a very costly thing. So I have to pay an overhead for that. So select joining too many tables to create a huge size table is one of the overhead. Updating affects many other tables. Deleting must guarantee the consistency of the data. It means that if I am deleting my record from my customer table, it means I need to delete it from everywhere in the bank. Correct? So not well supported for the mix of the unstructured data and the semi-structured data, although there are some data types being introduced into the current RDBMS, but still not an efficient way of dealing with the unstructured and semi-structured kind of a data. So not well scaling with a very large size of a data. So no SQL is no, it doesn't mean no SQL, it stands for not only SQL. So this provides a good solution to deal with these kinds of problems. So this is what I meant by scale in and a scale out. So this is what I'm doing while I'm doing the vertical scale in. So increase the capacity of the system nodes, use powerful hardware, but nowadays we know that the particular chips and everything is being provided at a cheaper rate. So it says, okay, let me provide this kind of a scalability. Add more nodes, allow better performance while using cheaper hardware. So that is why the trend moved on from the RDBMS to the NoSQL databases. So NoSQL says, okay, I will have give you the concept to deal with the big data along with the distributed databases concept. So that is how to handle the big data, this. So we dealt with scalability through a term that is called as sharding into a NoSQL. We dealt with the cost by dealing with a cheaper hardware. We had a flexibility of the schema. Right now we are not being constrained. So no cost constraint and other things are there. Then it is available over there. Although we have to compromise something over there. Can you tell what thing is being compromised since I am moving from a SQL or a relational database to a NoSQL database? Asset. The transactional support is being. Because what it says is, आपका Gmail कभी-कभी आपके phone पे update होता है और आपके laptop पे update नहीं होता है, correct? And later on, वही mail आपके laptop पे भी आ जाती है, आती है? So what it is eventually consistent, right? So I am losing something called as an asset, but eventually I am able to retrieve my data, so it's eventually consistent. So this is not only SQL, this is the definition for it. So these are some possible characteristics which I already dealt with. So who is using them? Facebook is using them, then Google is using them, LinkedIn, then Amazon is using them. So all the big market leaders are making use of the NoSQL databases nowadays to deal with big data. So the now main objective is to implement a distributed state, and main idea is to give up some of the asset constraints to improve the performance. But eventually the data will be consistent. It will not be compromising the consistency. Eventually it will be consistent through what? Through a CAP theorem. So CAP theorem is also referred to as a Brewer's theorem. So now these are some of the examples of the NoSQL databases, the white column stores, the key value stores, the graph databases, the document databases. So this was one of the, now this is just the current trend which I was trying to show to you. Okay, Oracle is dealing with all kinds of databases. Look, Oracle provides a NoSQL database, Oracle provides a RDBMS, Oracle provides a Berkeley DB for dealing with an XML data, and Oracle also have a strong transactional support for Oracle 11g Express Edition. So now this is what I was talking about. Okay, I have an e-commerce platform and I want to save the data regarding the shopping cart and decision data. And in the e-commerce platform, I have to save the data regarding the completed orders. Simultaneously, I need to store the data regarding inventory and item price, and simultaneously, I need to deal with the customer social graph also. Facebook, friends of friends data needs to be persisted. So now, which particular kind of a database is best for which one? So, for this one, key value store, one of the NoSQL database is the best one. For completed orders, the document store is the best one. For item and inventory price, the RDBMS or relational database is the best one. And for storing a customer social graph, a graph database is the best one. Right, now since it's a single e-commerce platform, for example, consider an Amazon, how to deal with these particular things. So the research question is this one, and the answer is this one. There's a term called as a polyglot persistence, which says that, okay, when storing data, it is best to use the multiple data storage technologies chosen based on the way the data is being used. So this is where the industry is and how they are able to persist the data. So with this particular polyglot persistence concept, they are able to deal with different kinds of a data, having a common API, and then dealing with different kind of database drivers for connectivity to different data stores. Correct? So this is just the same example, the same graph database, column families and others are being persisted over there. So now, what are we giving up? I already told. We are giving up choice, we are giving up group by, we are giving up order, we are giving asset transactions, we are giving a query language, that is SQL as a powerful query language. But then, is there a way out? That I can still have an RDBMS and still, for dealing with the NoSQL, can I do something? Yes. So, there's into the market this NewSQL. It says, you can deal with the big data, retain the properties of a NoSQL, and along with that, have an asset also. So take an asset from an RDBMS and deal with this one. So this is a NewSQL, correct? And the best examples of it are a NeoDB and a CockroachDB. So this is the example which I was telling. So this is a sample of the relational data, relation 1, relation 2 and relation 3. And this is while I persisted the same data into a NoSQL. Okay, this way, key, value 1, value 2, value 3, and this is the sample to it. And then, while persisting it into a NewSQL, I'm persisting the same data into a NewSQL. So now these are some of the research questions which you can have as a takeaway. So data storage, store different types of data using a single front end, as currently the particular companies, the markets is using it. Database connectivity, changing sample application while connecting front end with the back end. How to deal with a sparse data, how to deal with frequently evolving data, how to deal with a query efficiency, then considering big data scenario, how to simultaneously deal with the sparse data, the frequently evolving and the query efficiency. So these are some of the research questions on which the currently research is going on. See, these are some of the database research groups. So you can just have a glance at these are the prevalent database researchers group that are working on. Then this is the list of the topmost tier 1 conferences that are usually happening into the databases arena, and these are some of the references. Thank you so much. Any questions? Okay, thank you so much.